Hello everyone, welcome to another learning time with Miss Blessing, and in today's video we are going to continue our learning on decimals. In this lesson we are going to be learning about tens on a place value grid, tens on a number line, divide one digit by 10 and divide two digits by 10. Come along, let's learn together. We're going to start with tens on a place value grid. Here is a place value grid. Can you tell me how many tens and how many ones we have on this place value grid? Pause the video and have a go. Welcome back. Let's count how many tens we have. We have 1, 2, 3, 4. So we have 4 tens. And how many ones? 2 ones. So 4 tens plus 2 ones would give us what? 40. Remember, 4 tens represent 40. 4 tens divided into 4 gives us 10 each. So 10 times 4 is 40. So 4 tens represents 40. So 40 plus 2 gives us what? 42. Well done if you got this correctly. Here is another place value grid. Can you identify the similarity and difference between these two place value grid? Did you spot the black dots in the middle? Well done if you did. Both of them are similar because it has been divided into two parts, tens, ones, but over here we have what? Ones, tens. Now the black dots represent the decimal point, which shows us that the number on this side is less than 1, and that is why it's been written tens. So there are 4 ones, as you can see, 1, 2, 3, 4. There are 4 ones, and how many tens? 2 tens. So 4 ones plus 2 tenths is equals to 4 plus 0.2, which is equals to 4.2. Remember, 2 tenths is the same as 0.1 plus 0.1, which is equals to 0.2. So 4 plus 0.2 is equals to 4.2. Here is another place value grid. How many tens and how many ones can you see on this place value grid? Pause the video and have a go. Welcome back. How did you get on? Now let's count together. First of all, I can see there are no tens. But how many ones are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 ones. So this is going to be represented as 0 tens and 9 ones. So 0 tens plus 9 ones makes 0 plus 9, which is equals to 9. Here is another place value grid. This time around it's ones and tenths. How many tenths do we have? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. We still have 9 tenths, and how many ones? No ones. So this is going to be represented as 0 ones and 9 tenths. So 0 ones plus 9 tenths is equals to 0 plus 0.9. Remember, 9 tenths is the same in fraction as 9 out of 10, and as a decimal, 0.9. So 0 plus 0.9 gives us 0.9. Now if we add one more counter to this 0, already 0.9, how many are we going to have? 10 tens. So do we say 10 tens? This 10 tens can be exchanged for a 1 because 10 out of 10 is what? 1. So let's exchange this 10 tens for a 1. So our representation will now be there are 1 ones and what? 0 tenths. 1 ones plus 0 tenths is equals to 1 plus 0, which is equals to 1. Here is another place value grid. How many ones and how many tenths do we have on this place value grid? Pause the video and have a go. Welcome back. So let's count together. How many ones? 1, 2. How many tens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this will be shown as 2 ones and 12 tens. Wait a minute. 12 tens. Can we make an exchange here? Yes, if you said yes, well done, because there is 1 tenth in 12 tenths, so we can make an exchange by taking the 1 tenth over to the ones place. So we now have 3 ones and 2 tenths left. So our representation will now be there are 3 ones and 2 tenths. 3 ones plus 2 tenths is the same as 3 plus 0.2, which is 3.2. Now let's look at tenths on a number line. This is a 10 frame which has been divided into 10 equal parts. This is a bar model which has also been divided into 10 equal parts. And here is a number line also divided into 10 equal parts. Each of these represents 1 divided into 10, 1 divided into 10, and 1 divided into 10 parts. Now, if you observe, when I drew one counter here and I shaded one part here, and on the number line I have written 1 tenth. Now, if I draw another counter here, what will happen to the bar model? I have to shade this bar as well, and over here, what will I write? 2 tenths, because it has moved from 1 to 2, and on and on and on and on. Now, when all the counters are filled in, I have 10 tenths, 10 tenths, and on my number line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this shows us 10, 10. Each of these represents 10 tenths, which is the same as 1. Now, when written as a decimal, remember from our first video, 1 tenth is the same as 0.1, 2 tenths 0.2, 3 tenths 0.3, 4 tenths 0.4, and on and on and on until we get to 1. Now here is a clearer picture of what happens when we are counting in tenths. Now on the number line, the number is increasing: 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths. And on the bar model, the coloring, the shading is also increasing. When it was 1, only 1 part was shaded. When it was 2, 2 parts were shaded. 3 parts were shaded, and on and on and on it keeps going. This shows you the physical representation of what happens as we count on in tenths, and as decimal we have our representation as well. So what happens when we get to 0.9 and then 1? What do? We continue in 1. 11 tenths becomes 1.1, 12 tenths becomes 1.2, 13 tenths becomes 1.3, 14 tenths becomes 1.4, 1.5, 1.6, 1.7, and the same thing happens with the bar model, as you can see. And when we get to 2, what do you think it will become? 2.1, 2.2, 2.3, and on and on and on. Well done if you got this. Now I need you to pause the video and have a go at this. Estimate the position of the numbers on the number line. Where do you think 2.2 would be on this number line? Where do you think 1.5 would be? Where do you think 2.9 would be? Pause the video and have a go. Welcome back. How did you get on? Okay, we have 1 at the beginning and 3 at the end. Where do you think 2 should be? I think 2 should be somewhere in the middle. Well done. If 2 is somewhere in the middle, so where should 1.5 be? Here. 2 is here in the middle, so 1.5 should be in the middle of 1 and 2, because half comes here in the middle. 1.5 comes here. 2.2 comes right after 2, because 2.2, 2.1, 2.2. Once we get to 2, the next thing is 2.1, and then we have 2.2. So where would 2.9 be? 2.9 will be very close to 3. Why? Because right after 2.9 we have 3. Well done if you got this correctly. Now let's quickly look at dividing one digit by 10. First, we are going to recap again, a quick recap from our previous video. Now this is 100 square. 100 divided by 10 gives us what? 10. 100 divided by 10 gives us 10, and 10 multiplied 10 gives us what? 100. And here is a 10. 10 divided by 10 gives us what? 1. So there are 10 ones in a 10, and there are 10 tens in 100. Now when we look at one of these ones closely, you would observe we can also divide this one again here. We can actually divide 1 again into 10 parts. That single tiny cube can also be divided into 10 parts, and each of these parts represents 1/10. I explained this very well in the previous video. Please have a look at it. Decimal 1, and 1/10 as a fraction is written as 1 out of 10, and as a decimal 0.1. So here are 10 counters, and these 10 counters has been divided into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 counters divided into 10 equal parts. So 10 divided by 10 is equals to 1. And here is 1 divided into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 divided into 10 equal parts. 1 divided by 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The line shows how this was divided. 1 divided by 10 is equals to 0.1. So we know that 10 divided by 10 is equals to 1. Now, can you tell me what is the total of these counters we have here? All this has been divided into tens, and all of this 1/10 makes what? 1. 10 out of 10 makes 1. So can you tell me the number of tens we have all together? Pause the video and have a go. Welcome back. Did you say it was 5? Well done if you did, because this is 1, 2, 3, 4, and 5. So 5 divided by 10 would give us what? 0.5, because when we place the lines showing our division divided by 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you would see that in each group we have how many tens? 1, 2, 3, 4, 5, 5 tens. 1, 2, 3, 4, 5, 5 tens. 1, 2, 3, 4, 5. Each of these shows us 0.5, which is 5 tenths. Now here is another one. 3 divided by 10. Now here is our 3. 1, 2, and 3. Remember, this is 1 divided into how many parts? 10 parts. And 10 divided by 10 is what? 1. So we have 3 parts here divided into 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the last one, 10. Now in each column, 1, 2, 3, we have 0.3. 1, 2, 3, 0.3. 1, 2, 3, 0.3. So 3 divided by 10 is 0.3. This is how we make our division using counters. Now when we use our place value grid, remember to put your dots. First we have our ones, and then we have our tenths. This because this shows us that here we have less than 1. So how many ones do we have? 3 ones. We write our 3 here. So we need to divide these 3 ones by tenths. So when we are dividing using the place value counter, dividing by 10, we move 1 place to the right. So all these 1 moves to the tenths, 1 place to the right. So we have 1, 2, and then 3, and it comes over here to become 0.1, 0.1, 0.1. Remember, 1 divided by 10 is 0.1. 1 divided by 10 is 0.1. 1 divided by 10 is 0.1. So altogether our answer would be 0.3, like we have here. So once again, 3 divided by 10 is 0.3, and don't forget to put your dots in the middle, which shows our decimal. And when we are dividing by 10, we move one place to the right. So on our place value grid, we write ones and then tenths, and then we move the counters on a one column one place to the what? To the right. And when we do that, there would be nothing here anymore. Here becomes empty, and we have 0.3. Using a number is the same thing. Here becomes empty, our 3 moves here, and we have 0.3, 0.3. Hope this is clear. Okay, quickly let's look at divide 2 digits by 10. So Jane says, I know 10 divided by 10 is equals to 1. 20 divided by 10 is equals to 2, but you can't do 11 divided by 10. Do you agree with Jane? Pause the video and have a think. Welcome back. What do you think? Do you think we can divide by 11 by 10? Or just like Jane, do you think it's not possible? Well, if you've been following on this lesson, you would know it's super possible. So using our counters again, what number is represented here? This is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this 10 has been divided into 10 equal groups. 10 divided by 10 is 1. Now, what number is represented here? This is 1. 1 divided by 10 is equals to 0.1. Now, what number is represented here again? This is 10 and this is 1. So 10 plus 1 makes what? 11. And 11 divided by 10, what are we going to have when we divide by 10? You will see that in each column we have 1 and 0.1, 1 and 0.1, 1 and 0.1. So our answer would be 1.1. 1 plus 0.1 would give us 1.1. Each row shows us 1 plus 0.1, 1 plus 0.1, 1 plus 0.1, and our answer gives us 1.1. So we could do this. So here is 32 divided by 10. So first, using our counters again, we have 30, 10, 20, 30, and our 2 ones. So we have 1 and then 2. So when we partition this into 10 equal parts, in each column we are going to have 1, 2, 3, and then 0.1, 0.1, and 0.1 plus 0.1 gives us 0.2. So we have 3 plus 0.2, which gives us 3.2. So in each column we have 3.2. So you can either use the counters to help you divide by 10, or you can use your place value grid. Now remember, we learned that when we divide by 10, we move one column to the what? To the right. So here we have our tens because we have 3 tens, and how many ones? 2 ones. Don't forget to put your dot, and we're dividing by tens, so we have tens. So the ones move to the tens like we have here. The ones moves to the tens, and that is 0.1, 0.1, and the tens move to the ones. You move one column to the right. So the tens moves to the ones. Ones move to tens, tens move to ones. So we have 3.02. 3.2, excuse me. So 32 divided by 10 is 3.2. And when we use a part-whole model, we can partition 32 into 30 and 2. 30 divided by 10 is 3. 2 divided by 10 is 0.2. So 3 plus 0.2 gives us 3.2. So this is a Gettangle chart. Gettangle chart also helps us in our division by 10. Now, since on a place value grid we move 2 places to the right when we divide by 1 place to the right, excuse me, when we divide by 10, how do we use a Ketengo chart? Do we move 1 place to the right as well? Oh no, we don't. So but first we identify our numbers on the place on the Get and Go chart. So here is our 30 and then 2, here is 2. So we're going to move 1 place down, 1 place down, because we are dividing by 10. And when we move 1 place down, from 30 down here we have 3, and then from 2 down here we have 0.2. So 3 plus 0.2 gives us 3.2. So you can either use your counters, you can either use the place value grid, or you can use the Get and Go chart to help you when you are dividing by 10. I hope you understood today's lesson. Remember, practice makes perfect. Watch over and over again and keep practicing. The more you practice, the more you get good at it. And this is me saying bye for now. Please like, subscribe and share for more videos. See you in my next video.